Okay, so welcome. This is the last lesson. Today we will be doing exam simulation. The exam simulation is basically we will be looking at a previous exam that was done like in 2 years ago. And the idea is based on that exam, try to do all the process that you are supposed to follow to reach the final solution. And try to do all together like all the reasoning that you are supposed to do during the process. Okay. Of course, we won't be able to implement the solution because we don't have time, so we won't be doing the code during this lesson. But instead of doing the code ourselves, we will take a look at a solution that some of your colleagues did for that exam. And I choose like 3 possible solutions that got like the maximum grade. So you can also see what we are expected to receive from this final examination. Okay, so let me check. Perfect. So if you want, you can also download the text. It is here in the PDF in the schedule section of the course. It is this one called Solve My Riddle. Okay. So to start, I propose that we can read all together the text and try to follow like the whole process that you are supposed to follow. Okay. So. Okay, but before starting, did all of you already started to implement the exam? No? Okay. If no, it's fine. You still have time. Okay. Just to know. Who has already started to implement the exam? Okay. Perfect. Fine. So before starting to read the text, I would like to say some words on this diagram, because I mean the idea is to keep a mind on the big picture. So we have been always working on our computer and doing like the client on the server, everything locally, but we must take into account that at the end we are developing a web application, no? So the web application has several components. In our case, we always see all the code in the folders, and that's all. But what we were trying to implement along the course was something like this. And if we take into account that it has like many components interacting among them, this can give us a clue from where to start and how to approach like the whole exam and the whole implementation of the project. Okay, so in this diagram, well, I think, is it clear, this diagram to you? Is this familiar to you? More or less? So if we try to map this diagram to what we have been doing in the course, all of us can recognize that here we have like the front end that was the part that we implemented with React, right? So all the part with React that in our case was, let me see, this part, this upper part, was the part that in our project was under the client folder and was all implemented with React. Okay, so this is the client and is the part that corresponds to React. And this is what we call the front end. No? That is the part that the user sees and that the user interacts with. Then the lower part is all of the back end. No? That is the server side of our application. That part was all under the server folder, and it was all implemented with Express, right? This was like the backend, and here we had like the database. In our case, we didn't have any third-party services, but we had the database. that in our case was SQLite database, right? That is the file in which we save everything. So here we have the SQLite. That is this one, and boom. So why do I say this, or why did I want to show you like this big picture? Because in my opinion, and also like the best practice to approach this kind of application is to take like a bottom-up approach, no? Starting from the bottom, that in this case is the database, and then going up to the to finish with the front end. So my advice for this project, for this exam, is to start by working on the database and then build up until you reach the front end. What is the reason behind that? The reason behind that is that when you work on the database, you define the information that the application will be consuming. So if you are not sure which data the application will be dealing with, you can't build the functionalities on top of that data, and you can't build then the graphical interface on top of that functionalities. So let's say like the natural approach to these problems is first to make sure which data we will be dealing with in our application. Then on top of that data, which functionalities are we going to offer, that the functionalities have to do with this business layer, that is the API. So which endpoints are we going to expose? And then finally we have the presentation layer. Okay. Okay, just to complete the map, this data layer that we see here in the backend, in our case, is represented technically as which files represent that layer? All the DAO files, no? That are the ones that enable us to connect the API with the database, or that manage the communication between the API and the database. Okay. So please don't lose the big picture, that is this one. Also, an important thing to take into account when implementing the solution. Okay, as I was saying before, we have been always working on the application, just us, no? Just we interact with the application just us, as if we were the only user of the application. But please take into account that in this case, a web application is a distributed application. That means that by nature, here you won't have just one single user at the time working on the application, but here you have like several users, no? That might be doing like all the requests at the same time. So I don't know in the specific case of your exam if you have to take into account some kind of, let's say one user starts playing the game, and at the same time another user starts something. I am saying things randomly, okay? But it's just to say that always have in mind that this application should be used, or should be designed to be used concurrently by several users at the same time. So it is not just for one user, it's not just for us or for you, but many users can potentially be using the application. And if that's the case, and if there is some functionality that we must deal with different users, or with the fact that a second user has starting to do some operation while the first one was doing the same operation, you should try to deal with that kind of complexity. Okay, let me check. Okay. Okay, so today's roadmap will be, and I suggest also, as I said before, in your case, try to do the same way. First, we will try to design the database, which means try to define which tables do we need, which columns do we set in each table, and how we try to associate or to link one table to the other. Then we will work on this part that has to do with identifying the functionalities that we need and the endpoints that we need. And finally, I will show you how your colleagues implemented this part. Indeed. Okay, the second should be, okay, after doing the database, you can start working on the DAO, that is the files, and you will try to define which SQL queries are you going to do to the database to get the relevant information. Then, after that, you should be working on the API, and finally on the React application, okay? So up to now, everything clear? Perfect. Okay, so this was the text. I also choose this one because also this one is a game. So somehow it's similar. It's not the same, but somehow it's similar. It has like the same goal, that is, yeah, to implement a game. Okay. So, let's try to read it together. The first thing that I would do over the text is try to identify the entities, the involved entities that you can find there. So an entity is like how to explain an entity? Like the roles or the relevant things that you perceive that you have to represent in the application, no? So the information that you will be dealing with. Typically, you can find the entities in the text by taking a look at the articles in the text, no? So when you find like the something, typically that thing that is there might potentially become an entity. Not everything is an entity, and not all the entities that you find here are going to be represented on the database. Some of them will. So that's the first thing that we must distinguish. Okay, so this one says, design and implement a web application for managing a game platform based on posting and solving riddles. In the following, user means any authenticated and login user, while anonymous means any user that is not logged in. Can you please there? Okay, so every user of the application may post one or more riddles that other users might try to solve. So up to this point, we might say, without having read everything, that we have like two potential entities there, no? Two potential important, relevant information that we will be dealing with. One of them is the user. No? It says that it has users that we will be dealing with. So let's do the entities with yellow. So we have the user here as a potential entity, and we also have these riddles, okay? Because the user will be interacting with the riddles. Do you know what a riddle is? It is, okay, I don't know how to explain. What is the word in Italian for riddle? Indovinare, okay. Okay. I didn't know what it was, so but if everyone knows, it's fine. So then we have a riddle is characterized by a question. a level of difficulty, a duration, the correct response, and 2 hints. So from that sentence, somehow we know that that information corresponds to the information or the data that represents or that corresponds to a riddle, okay? So we will take a look at that information later because we will use that information to design the database. But up to now, my advice is in the first time you read the text, try to identify just the entities. Then, once you have identified the entities, do another read to identify the information, and then maybe another one to identify the relations, okay? So at that point, you are sure that you have understood everything and that you are representing everything. Okay, so a riddle is characterized by a question. Okay, we already saw that. At this point, we might say that a question could be, we still don't know, we are not still sure, but might be an entity, another entity. Okay, a level of difficulty, a duration, and 2 hints. Okay. The duration is specific for every riddle, and the duration period is measured starting from the first response submitted by a user. So here we have response by a user. A riddle may be posed by any user, and all the users may attempt to answer it within its defined duration. The first user that provides the correct answer, so here we have answer, but we already have had the response, so let's say for now that it seems to be the same, gets a score. The riddle becomes closed and no further answers may be given. If no users provide the correct answer within the defined duration, the riddle automatically becomes closed. Okay. In particular, the system should support the following functionalities. A user may create a new, okay, so up to this point, let's say that the data we will be dealing with should be like described in this first part, okay? Because up to then we have the functionalities. But as we saw in the diagram, the functionalities are built on top of the data. So more or less we can say that up to this point, we can't somehow distinguish the data we will be dealing with. So up to here, do you identify any other entity or important data we should be dealing with, apart from the user, the riddle, the question, and the answer? No. No, I think they might be enough. Here, concerning the functionalities, we have that a user may create a new riddle by providing all the necessary information. A new created riddle is in the open state that enables to enter the replies or the answers to that riddle. Then the user may see the status of all the riddles that he has posted as the author of them. If it is closed, the author will see all the given answers by the other users. If it is open, he can see the current answers. Nothing very special. Any user in the system, meaning also the users that have not been authenticated, can see all the riddles classified by open and closed ones with the questions and the difficulty. By selecting a closing one, the riddle shows all the given answers that were given to that specific riddle, and who has got the correct answer, if someone got the correct answer, and Okay, and if it is open, he can participate and he can try to send like the reply. Then there is a countdown for the remaining time. That is, this thing is very similar to the one that you are implementing, because you also have like a countdown, no? Like when the game starts, from when the game starts until, well, I don't know how much time do you have there, but somehow that functionality is the same in your case. So also here there is like a countdown, and according to this percentage, the first or a first or a second hint is shown. Okay, so when the user starts to work on the riddle, the countdown starts. When he reaches the half of the time that he has available to solve the riddle, it will show a first hint, and then when he reaches like a 75% of the available time to complete the riddle, he will show a second hint. Okay. And according to when the user answered the riddle, he will get 3, 2, or 1 points, depending on the difficulty of the riddle. Non-authenticated users will see all the riddles, but they can see the replies and they can't answer to the riddles. Okay. Then it says that anonymous visitors and also logged in users can see the top 3 ranking of the users, so the ones that have solved more riddles or that have got like the highest score. Okay, and well, it shows like the first 3 users. I don't know if this sentence is also in your text, that it says that the graphical layout is up to you, so you can decide how to organize everything graphically and well, decide how to display everything and how to structure everything. So, okay, coming back from here. So at this point, we have that in our table or in our database, for sure, we will have to represent the fact that we have a user, the fact that we have riddles, and the question. Should we represent the question as a different entity? Probably not, because at the end the question is something that belongs to a riddle entity, no? Something that, like, we can say that a riddle has a question. So it is not an entity itself, but it is information that belongs to the entity that is the riddle. Okay? So it's a property of the riddle instead of being different, something apart from the riddle. So at this point, we can say that this question, has no sense as an apart entity, but it is information that belongs to the riddle. And we have the response. Do we need to represent the response as a different entity? Or how do we deal with the answers that the users give to a riddle? Because up to now we have the users, no? And on the other side we have the riddle. So how do we somehow link them or associate the one to the other? Because if we just have 2 tables, how can I say the user 1 gave this answer to this riddle? At this point, we can't, just with 2 tables. You know what I mean? Because we are not saving anywhere the answer or the possible, the answer that a user is given to a specific riddle. Okay? So based on that, we can infer that we will need this response. Okay? That we will also have to represent this response as a different entity. Okay, so what does this mean? That the entities that we have identified in the text will become tables. Okay? So from here, we can say that in the database, we will have one table that will be users, the second one that will be and the third one that will be answers. Okay. When doing the tables, don't forget that the name of the table usually goes in plural. Okay, so users, riddles, and answers. Okay. Which information do we have to? Okay, the easiest one maybe is the riddle, because we have explicitly here what information characterizes a riddle. So here we have the question. So after identifying the entities, we will identify the data that each entity has. So for the riddle, we have the question, we have the level of difficulty, a duration, okay, the correct response, and 2 hints. Okay, the duration was already there. Okay, apart from these ones, do we need to represent something else? The state, yeah, for sure. We had this one. Maybe for the first use. So we knew that it might be closed or open. So let's say we have here the closed and okay, yeah, for sure the state. Is in the open state. Okay. This one is kind of tricky because in the first paragraph, if it didn't say nothing about the state, but then when describing the functionalities, it says that it is open or closed. So from that point, we infer we must have an state. Okay, yeah, for sure the state. Something else? The author of the, yeah. We must have the author. Yeah. For now, let's. Yeah, for sure. This one is tricky, but you know that the riddle starts and then there is like the duration, right? And from when a user tries to solve the riddle, a countdown begins. So the question is, do we have to store somewhere the time at which a user started to work on that riddle, or we don't have to store that time? How do we know that a user has already completed all the time he had available to solve the riddle? Do we have to represent when the user started to work on that, or we can also provide this functionality without having it stored somewhere when the user starts to work on the riddle? You know what I mean? Let's say for now that we will somehow store the timestamp of when the user started to work on the riddle, so that we can know if the user had already completed or if he had wasted or used all the time he had available to solve the riddle. Okay, so up to now it's fine to say that we will save somehow the start time. Okay, so okay, so up to now we have identified that for our entity riddles, we have the following information that we need to save, and because we will need to deal with that data in order to implement the functionalities. For the, okay, so the other one that we identified was the author of the riddle. So how do we save the author of the riddle? Because one alternative might be to create a new field here inside this table, riddles, or the other one would be to do a relationship between the user, between one user and the riddle by stating that that user is the author of the riddle. Okay, so for sure here we will have then a field that is author, and it will be a foreign key that will point to the user's ID. Okay, so in that way we can manage or we can represent that a user is the author of a riddle. Okay, which information do we have to represent from the user? I think it didn't say anything, right? In the text, it was not explicitly told that a user had a name or something like that. Typically, we can infer that a user has, well, yeah. Let's say a name. For sure, he has an email. Of course, he had this ID that in the database will be an auto-increment ID, no? Something that the database will manage both. Independently, he has the user, he has the email. What else? How are we supposed to deal with the authentication and with the logged user and the signed-in user?
Password and so on.
We need, of course, the password. What else? Do we need to represent something else from the user? Maybe not. And then finally, the answer. So what information or what is the purpose of this answer entity? It is to link a specific user with a specific riddle by saying that the answer was provided by a user in regard to a specific riddle. So it is basically an intermediate table between the users and the riddle. No? So for sure here, okay. Also, of course, the riddle has its own ID. Also, the answer has its own ID, that is an auto increment 1. And here in the answers, we have the user as a foreign key that will point to a specific user, and the riddle as a foreign key that will point to the riddle. Okay. So are we satisfied with this design of the database? Are we missing something? Okay. Ah, no. Okay, this one we already had. This one, the correct response. How do we represent, or how do we complete this functionality? There is the winner user. No, he might receive like several answers, but just one user will be the winner for that riddle. No, so up to now we don't have represented this fact that one user is the winner. So how can we adjust our database to represent the fact that there is one winner for the riddle? In this one? Okay, and that field would be pointing to, yeah. Also, in my opinion, that would be like the most practical and the most elegant way of solving that. By saying here, that we will have a winner that is a foreign key to the users. No? So that a riddle is linked to the users in two aspects. One, to represent who is the author of the riddle, and the other one to represent who is the winner of that riddle. Okay? Are we missing something else? I don't think so, but well. Okay, why are we doing this? I mean, in this way, this stuff, because it's what you are expecting to do with your text, no? So my advice is try to follow this approach in the sense that maybe read it for the first time and try to identify something. And on a piece of paper, try to write that, like the important entities and the information. Usually, the final design of the database you won't get at the first hit. So you will have to read again to see if you were missing something, if the data that you have identified is enough to support the functionalities that you are required to implement. You have to, well, like do what we have done here, like very with calm, and see if everything that you have identified is enough. So please, please, please devote some time to read several times the text. If you understand the text fine and you implement the database fine, the probability of success is high, because when you are implementing the front end, you find out that you are missing data or that you were not representing some information, it is painful to implement that kind of stuff when you are already on the top of the application. So it is better to devote a lot of time in designing the bottom of the application to make sure that everything there is fine, and then upon that start building everything. In your exam, have you already identified like which entities or which information will be you dealing with? Which ones? I am. What is the exam about? The game, the meme. Okay, yeah. So of course, one of them will be the meme. Okay. Then what else? I think also the user has to be represented. So in that sense, it's pretty similar to this one, because there is one author that creates the meme. There are other users that participate to get like the correct answer. Sure. Like each meme has the questions, the possible answers. No, has a list of associated answers. Yeah, I'm saying something. So there is a meme that has like the possible option, the choices, and two of them are the right ones. No. So somehow at that point you have, of course, you have to check it with. But we can say that there is a meme that there are the choices, that there is a relation between the choices and the meme that has to, in order to represent that for a given one, there are two possible good ones, and that for that specific one, the choice is correct or is wrong. What else? Oh, I don't know. But okay, the message is that one. Try to read carefully the text and try to read it several times until you are sure that you identified everything, and upon that you can build the meme. So here, the first step we can say is checked. We have already identified the entities, and we have already designed the database. Then the second step would be to try to identify the functionalities, and based on the functionalities that they are requiring to us, to design the API. No? So which endpoints are we going to offer to the front end? This one is a little bit more tricky and requires more time, but well, let's try to do it very quickly from here. So which functionalities do you think are useful here? Or which endpoints are you can imagine that you will be creating to implement this application? So obviously, as a trick, we said that the entities usually in the text are followed, have like an article, no? So the riddle, the user, the answer, something like that. The functionalities, instead of an article, what they have is a verb, no? Because they represent what the application is supposed to do, or the functionalities that the application is supposed to provide. So in this case, which verbs we can identify on the text? Okay. So this one, no? May post one or more riddles. So it means that we must provide an API that enables a user to create a new riddle. Okay. A riddle may be posted by any user. All the users might attempt to answer the riddle. So another possible functionality is this one, to submit an answer to, the first user that provides the correct answer gets a score. So, well, maybe also dealing with the scores or setting a score to a user might also be a functionality. Okay, here is provide the correct answer. So we already had this attempt to answer it. Maybe we can think that from the backend, we might get something that tells us if the answer was correct. So something like verify. Well, something as verify answer. So the user may create a new riddle. We already had this one by providing all the necessary information. Here, for instance, since it says that all the users will get the information from the riddles or will be able to see all the information from the riddles, of course, we know we will need to have something such as get, well, as a get, that gets us the information of a single riddle. So something as get. Maybe based on an ID, no? So if I pass an ID to the application, I need it to retrieve I want to retrieve all the information from that riddle. So, well, that's probably one functionality. This one, for instance, the author will see all the current answers. So maybe get answers. So if I give you the ID of a riddle, I want the server to give me or to retrieve me all the answers that have been given to that. So here, I might want something like get answers. And, well, it will get as a parameter let's say the riddle ID, no? This one is different. I mean, the get answers is, of course, is different from get riddle, no? The get riddle gives me just like the basic information of the riddle, while get answers gives me a different entity that is all the answers belonging to that riddle. This one, for instance, the user might see the list of riddles divided between open and closed ones. So maybe we can also think of a functionality or an API that retrieves like all the open ones, no? Like get open or get closed. That gives me the list of all the riddles. So. Indeed. We already had like submit the answer, right? Yeah, this one, that is try to answer. We'll see the list of all the riddles that we already have it here. No, that one, for instance, we are still missing that one. That is this one, like get all the riddles. So we in this case, for instance, observe that here you are supposed to get the list of all the riddles, but without the question and the difficulty. No, I mean with the question and the difficulty, but without the replies or the correct answer. So in that case, we must make sure that that API retrieves just the riddle information. Because even if you don't show the user, because if, for instance, you created an API that retrieves everything, even if you don't show graphically in the graphical interface the other information to the user, he somehow, by taking a look at the request, can also get the information that you are getting from the server. You know what I mean? So from a security point of view, it's not safe enough to get all the information from the server, but just get the information that that specific user is supposed to see, even if you don't show that in the graphical interface. Okay, so if here it specifies that a non-authenticated user will be able just to see the question and the difficulty, make sure to have an API that retrieves just the question and the difficulty. Don't use an API that retrieves everything. You know what's the sense?
What about answers? What if you don't want to show the answers and you have to take it from the server?
No, but in that case, for instance, if the user still can't see the answer, you should not be retrieving from the server any request that has the answer included.
Okay, so the answer should be on the React application?
No, the answer, I mean, getting an answer from the riddle or from the Mimi, for instance, should be a different endpoint that you are sure you will be invoking just if the user is authenticated or just if the user at that point of the game or the application has the permission to get the answer. Okay. No? In your case, for instance, you must not do the mistake of downloading everything from or getting everything from the server at the first time the user starts the game. No? Because at that point, if the user knows, he can take a look at the console, see what he got from the post or from the get that you did from the server, and find there the answer. So make sure, especially, and that's a good question. So make sure in your case that is a game and that has a correct answer, that you are creating the specific APIs that enable you not to provide the answer to the user before he can get that answer. So try to do the APIs as atomic as possible.
So it should be like an image that is the meta itself, and then 7 answers.
And then 7 answers.
The user doesn't know
Which one is the correct one.
Okay.
So you will have an API to get choices, for instance, that at that point retrieves just the choices without any indication of which one is the correct one. Then when the user submits his answer, you will have something like a post API that is a verify answer that is similar to this one, no? And at that point, on the server side, it will be the server who decides if the ones that the user submitted were the correct ones or not. And we'll retrieve something such as a very simple API, such as it was the correct, or a single item to indicate if it was correct or not. Okay. Okay. This one, we have the top 3. So for sure, we will need an API that retrieves the top 3 users. So here we might think of something like top 3. Okay, so I mean, this is not, of course, we are not doing this very exhaustively, but we are doing like I'm trying to show you like the process to follow. But let's say that for now, these are like the functionalities that we have identified. So this one is like a new riddle. This one is like answer the riddle. This one is verify answer. This one is to get a single one. This one is to get the answers based on the riddle ID. This one is to get the opened ones, the opened riddles, the closed ones. Okay, this one is to get all the riddles in the platform. And the last one is to get the top 3. Okay, so once you have defined like or identified the functionalities or the data that you will be getting from the server, I think that what we might try to do is try to translate this into API calls. No? So an API call is typically identified by the identifier, what it does, and the HTTP method. No? Do you know what is the HTTP method? The get, post, delete, or what is the other one? Put. So in this case, it is new riddle. So as we can infer that it requires information to be passed, we might say this is a post. This one that is providing an answer, we can say for sure it will be a post. The HTTP method for this thing will be a post. Verify answer, I think it might also be a post, no? Because you need to pass something to verify. You are sending your answer and saying, verify if the answer I'm giving is the correct one. No? Since we are submitting information to the server or parameters, we say that this one is a post. This one I already wrote, it is a get, that is the riddle based on an ID. These get answers, we might also think as this one as a get. The open and the closed ones are for sure gets. No? Like give me all the closed riddles, the open ones. This one, that is the list of all the riddles. It is, of course, a get. And the top three, it is a get. Okay. So I hope that you can understand this I have wrote then. But at this point, what have we done? We were here in the business layer, and we were trying to identify the APIs endpoints that we will be using. Of course, we also have to implement this part that has to do with the SQL. With the SQL queries that we will be doing to the database to retrieve the information. But, well, okay. So, as you can see, we're working this from a bottom-up approach. No, starting from the database, then from the database we are designing the API, and up at this point we already know which functionalities are we going to provide to the front end. Okay. So up to now, is everything clear? Okay, so yeah.
Sorry, is it allowed to send the ID where the column attribute of the table specific of the database to the client application?
No.
Identify each answer in this case, and you have to decide which is the right one.
Yeah, it depends on the context. Yeah, in some cases, it might be an option, like to submit everything with a get, and with the get, we know that we are passing that information directly on the path, no, on the URL that we are submitting. Okay. So, if it is not sensitive information such as the user ID, for instance, the user ID is something that typically we don't want to pass with the URL, because somehow it gives some hint of how are we dealing with the users in the database. If we pass the user ID, a normal user of the application might know that in our database, the user that corresponds to Juan has the ID 5, for instance. So typically, the user ID is not something we want to pass on the URL. Also for the answers, maybe we don't want to provide that much information about how the things are stored on the database. So in that case, like the safest option would be to pass that through a post. Through a post, so at least not showing that on the URL.
So the can be used, but not on the URL. You can use it in the post, because I was thinking, how can I identify within the database the answer?
Yeah. Well, let's say that it depends on the context and the reasoning, or the reasoning that we should be doing to distinguish if passing that on the post or on the URL is if that's sensitive information. It's if you consider that the information that you are passing there directly on the URL is not that sensitive, or that you are not, let's say, providing the answer directly on the URL, it's fine to pass it through ID. Yeah, in your specific case, if you pass just the ID of the answer, it's fine, no? Because with the ID, potentially the user can't know what the answer was, what the correct answer was. I'm trying to think of a case that maybe the user can infer what was the correct answer by taking a look at the ID, but I think it's unlikely that that case happens.
So we can use it in.
So you can use it as in the get. Yeah. Yeah.
Okay.
Yeah. So in that case, it's fine if you pass the ID in the URL. And okay. Any other question? Okay. So as you have seen, we have done like all the design of the backend. And my advice is also, if this seems like not useless, but as something minor or not functional, but let's try after, in your case, after designing the backend of the application, immediately try to document it on the README, okay? Because I mean, this README is in your structure of your exam, that you have the client, the server, and you have this file README, in which you are supposed to document and to explain the decisions that you have made in the design. So in this case, or what I suggest to you is immediately after doing what we have done, come here and try to write everything here. Let's to make it formal, which tables are you going to be using, what each table means, which are the fields on each table, and also to document the API, okay? Somehow this file is contrary to the order that we are following, because on the first part of the file it asks for the front end, and at the bottom there is the back end. So you should work it on the opposite way it is presented here. But so, well, yeah, the advice is don't forget to do this, and try to do this even before starting to code, okay? Okay, so let's do this way. Let's make a pause here, and then in 15 minutes, like around 10, we will start again. I will show you the possible solutions that your colleagues did for this exam. I will show you the README and how they design everything from the database to the final application. We can maybe try to run the application so that you can see the graphical interface, how does it look, and what we are expecting in terms of this, let's say, design. And so it is 10 minus 10, so we see here at around 10:05.